Hello and welcome to another Blue Monkey Forensics video. In this video, we will look at how to perform a live capture and use incident response tools on a live Windows box. Please help me out by hitting the subscribe button so it can reap the wild wind. There will be circumstances where you will encounter a live system and a decision is made that you cannot shut it down and must extract critical information. Reasons behind the decision could be that the legal authority does not allow an interruption to the company's servers, or that there is encryption being utilized and shutting down the computer may result in lost access to unencrypted data. Here are just some of the artifacts you may want to collect, and we're going to be using PowerShell to perform the collection. There are other methods of performing triage with more automated tools, but that will be covered in other videos. But it is important that we understand the concepts and how to do this manually. To launch PowerShell, you can left-click on the Windows Start button and then type in PowerShell. And then select the Windows PowerShell and then run as administrator. This is because some of the information we want to access is restricted from a normal user. And then once we're in PowerShell, go ahead and change the directory to the staging drive that you have inserted into the target machine for data collection. In my case, my D drive is my staging drive, so I'm just going to head and type D:. And now as you notice here in the prompt, just like on MS-DOS, it gives you the path that you're in, and D:, or my staging drive, is where I want to be. One of the system artifacts that is usually important in forensics is the date and time of the system. To obtain the system date and time, we can use the get-date command. So we can type get-date, and then here we're going to get fancy and then pipe it to the t-object, specify the file path, and then the name of the output file, date.txt. And then we're also going to specify the -append option. So what we're doing here is we're going to pipe the output of the get-date command into the t command, which is going to send the output to two parallel streams. One stream is that it's going to write into a file that you specify, in this case date.txt, and then the second stream is going to go to the screen. So once we hit enter, you can see that the date time gets echoed onto the screen. And then it's also written out to that file. And we're going to verify that shortly. But before that, I want to shorten this even a little more by using the alias for the t-object command. So we're going to just type get-date, pipe it to t-a, and then specify the output file of date.txt. So once we hit enter, so this basically does the same thing as the longer version that we did first. The longer version just is the more proper way, right? Because it spells everything out and it's nice and clear. But because I'm lazy, I'm just going to do this the easy, quick way. And to verify that it did what we wanted it to do in terms of writing out to the file, we can use type date.txt. And when we hit enter, we will see that this will have two dates on it, right? Because we ran this twice. So remember, the -a or the append will append to an existing file or create an empty file. Another important time-related artifact is the time zone of the system. To obtain the time zone setting, use the get-timezone command. So we're going to do get-timezone, and once again we're going to pipe it to t-a and then a different file called timezone.txt. So we see here now that we get the time zone name, and then the offset from GMT, and then whether daylight saving time is supported. Getting the system information in terms of OS version, the install date, the boot time, etc. are all important, and we can use the get-computerinfo commandlet to accomplish that. So go ahead and type get-computerinfo, pipe that to t-a, and then our output file is going to be called computerinfo.txt. So this comes back with a ton of information. Some of the items which may be of interest to us would be the Windows product name, right? Because this gives the window product name such as Windows 10 Pro or Windows 7, etc. We also want the information that's called the Windows install date from registry, because this gives us the Windows build date, right? That could be of importance to your case. Another field is the CS manufacturer / model, right? This gives the make and model of the hardware. And then something called CS name, which is the name of the machine. And then another thing about hardware that we are interested in is the hardware adapters, the network adapters. So you can take a look at CS network adapters, which gives us the networking adapters that are on this computer. Another thing that may be of forensic importance is the last boot up time, right? So we can look for OS last boot up time. So there, again, there's just tons of information on here. It may or may not be of immediate importance to your case right now, but it's all part of that command line. So you might as well grab it and then filter it out later if you don't need it. And there's a similar command that will get you most of the same information, and that's called system info. So we're going to do system info, pipe that to t-a systeminfo.txt. And like I said, it's got a lot of information as well. Most of it is overlapping, but it's just another view of the system. Obtaining user account information can be done via the get-localgroup command. So we can do get-localgroup, pipe that to t-a, and then specify localuser.txt. This is going to show all the local accounts, whether they're enabled, and then the description of the account if available. And if you want to get more details on each user, you can add the -name option with the username, then select all the data fields that you're interested in. So get-localuser, -name, pipe that to select star to grab everything, and then pipe that to the t-a examiner.txt. So in the output, you can see there's a field for enabled, whether the account actually is turned off or not. Tells you the full name if that's there, if the account expires, password change dates, password expiration dates, whether a password is required or not, when the password was last set, the last login time, the SID, all that kind of stuff. Similarly, if we want to obtain group information, we can do that via the get-localgroup command. So we can do get-localgroup, pipe that to t-a localgroup.txt. And if you want to get the members of a particular group, you can get the get-localgroupmember command and then specify the group that you're interested in. So in this case, if I'm interested in seeing who the administrator accounts are, we can do get-localgroupmember administrators, and then pipe that to t-a localgroup.txt. And we can also get a list of the environment variables and their values for the particular user that we're using right now. And so you can do get-item env : and then pipe that output to t-a environment.txt. So some of the interesting items could be the computer name, the home path, right, a user profile, where the local app data folder is, where the temp file is, etc. Another really important set of data to obtain in incident response is the running processes. We want to see what the system is doing, especially if you're working on an intrusion case. So we can run the get-process commandlet, and then pipe that to t-a processes.txt. And then as you can see in the output, there's a lot of stuff here, but the important things are probably the process ID, right? And then the name of the process that's running. Another thing that we want to get is all the running services. And so we can do the get service commandlet, and then pipe that to t-a services.txt. And here you can see it lists out all of the services that are available on the system, right? They are listed alphabetically. And it also gives you the status, whether the service is running or whether it's stopped. And then actually gives you a little bit better description of what the service is besides just a name. And if you want to display the output in a different format, we can pipe the get service command to the select object commandlet and then name of the objects that you're interested in. So for example, if we're interested in the name of the service, and then the display name, which is like the long format name, the status of it, what kind of service it is, and then the start type, whether it's manual or automatic. And then it'll list all those out. Another thing we can do in this related area is look at the task lists. So we just type task lists /v/FO and then list. This will give you all of the tasks that are running, right? It gives you the name of the task, essentially what the what the program is that's run it, what the process ID is, how much memory it's using, what is the name of the user that launched that particular service, CPU time, and so forth. Right. Another thing that's related to processes and services is the startup list, right? So this is a list of programs that get started by the system automatically. So we can use the WMIC command and then tell it that we want to look at the startup and then list it out. And then once again, we're going to pipe that into t-a startup.txt. Unfortunately, this doesn't look great because it just kind of runs over each line. But for the most part, what you're looking at is the name of a particular program, where the executable is, and any options that was given. And we can also look at automatically started processes by doing the get item property of a very specific registry key, right? So we're looking at the HKLM:\software /wow6432 node /Microsoft /Windows /current version /run. One thing you'll notice as you're typing these long registry keys is that at any point you can hit the tab key and it will do the autofill if you have enough of the characters typed in for the computer to figure out what you're looking at. All right, so the next thing we want to look at is the network related information. So the first thing we want to look at is the host name, which is the name of the machine that we're on. So we just type hostname, pipe that to t-a hostname.txt. We get back the name of the machine. Next thing we want to do is we want to grab all of the configuration for the network. And we can do that with the ipconfig/all and pipe that to t-a ipconfig.txt. And we can see the network configuration for the machine that I'm on. Another way you can do it is using the get-netipconfiguration commandlet. And this returns similar information for each of the network interfaces. Next thing we want to look at is the active network connections. Right? So we want to see what all the connections are on the machine and any listening ports. Again, this is really critical if you have an intrusion case to see what's going on. So the command we're going to use is netstat, and then the options that we are going to use is -n to display in numeric form all the addresses and port numbers, -a to display all the connection and listening ports, -o to display the process ID associated with each connection, and then lastly -b to display the executable involved in creating the connection or listening port. And again, this is important because we want to know whether malicious code is executing on the system and what it's doing. All right, so now that we see the output, and let's say we identify a particular process to be a malicious process because you look at the port and go, you know what, nothing should be listening to that particular port. So this does not seem like a valid process on my machine. So you can actually get more detailed info. So what we can do is use the get process commandlet and pipe that output to only look for the specific process ID that you're interested in. So you pipe that to where ID dash equal and then the process ID number. Pipe that to select dash object, process name, comma ID, comma path, comma start time, comma modules, and pipe all of that to t-a, and then we can put in the process ID and details.txt. So as you can see from the output, it gives us the process, right? The name of the process ID, right? That's actually what we gave it, so it better be the same thing. And then the path of where the executable was for the process. So this is one of the places where you can get a clue, right? If the path is in some odd, bizarre place, then this may be a malicious process. It also gives you the start time, right? So you can have some idea of, hey, if things start going bad on January 1st, 2021 at 4 p.m., and this process started at 4 p.m., then you know this might be the culprit. And then lastly, it tells you all the modules, all the DLLs that's involved in this particular process. So once again, if you have DLLs that are not recognizable, then you may have an intrusion. Another really important piece of information you want to know during a live capture session is whether encryption is active on the machine. In particular, let's look at the BitLocker status with the manage-bde command. So we can do manage-bde-status, pipe that to t-a, bitlocker.txt. And the output tells you basically if BitLocker is enabled for any devices, what version it is running, the status, right, whether it's in the middle of converting the entire volume or it's already done, the percentage that's encrypted, and so forth. Let's get a file listing for the system using the tree command. So we can do tree c:/f, and the F option is to obtain the file names in each directory. Otherwise, the tree command will just list the names of the directories and not its contents. And once again, we're going to pipe that to t-a file listing.txt. And here you have the file tree. All right, so the last thing that we're going to do is we're going to get the history of the commands that were run. And the reason why we're doing this is for twofold. One is we actually can get a log of all the stuff that we did, right, to prove that from a forensic standpoint we didn't alter the evidence in any other way that we're not documenting. And two, if the command windows were already open or the PowerShell windows were already open, you can now see what the users did on those windows. So the commandlet we're going to use is get-history. We're going to pipe that into t-a history.txt. So as you see, this is the history of the stuff that we did when we opened up this PowerShell window. But like I said, if this window was already in existence, then you'll get all of the commands that the user had typed in. So make sure that you run the history command in every open command window. To push this a little bit further, we actually want to get the full properties of the history entries, because one of the things that we want to do is get the date and time of when the command was executed. And the get history command is also alias to the word just history. So we can type history, pipe that to format-list-property star, pipe that into t-a of history.txt. So now we see for every item that we had in the list, it also gives you the entire command line of what was typed in, the execution status, right? It could be completed, it could be killed, terminated, and then the execution time, when it started and then when it ended. All right, so that brings us to the end of this video where we learned about live capture concepts and incident response tools on the Windows platform. Grabbing date and time, system information, checking for destructive processes and active encryption software, network connections, and lastly, history of commands typed, all just a small part of performing a live capture. Hope you enjoyed it, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.